Buddy, it looks like people are starting to trickle in. Perfect. Hello, everyone. My name is Greg Marcoux. I'm one of the assistant directors of admissions. By this point in April, I'm sure many of you have been to some of our webinars already, so I'm sure you've seen on my face it probably at least once. A welcome to joining us today on the Nuclear Engineering Department overview webinar. I'm going to go over kind of just the chat feature. Again, if you have any questions, submit them on the chat. We will get them. It is a moderated chat, so when you submit a question, it will not populate in the chat right away. We will see it first, and we will kind of control when the questions come in, just to make sure that we're not being less confusing and answering one question at a time. So if you've submitted a question, I promise we already have it and we will get to it. So on that point, I will pass it over to Kate and Tom.
Hi, everybody. Welcome back to those of you who've been here for one of our other presentations. And thank you for joining us today. And just send us your questions. I'll join in at the end to help answer them with Tom. And then we have Professor Zeke Blaine, who's going to be joining us. Hopefully, he's setting up his webcam. So he will be in shortly.
All right. I'm Tom Haley. I just put a message in the chat. That's my email. On the off chance that suddenly everything goes dark and it's all over and you try and log back in and it said, this meeting is closed. Well, we're going to send out, contact us and we'll send out some kind of broadcast email. I guess, Kate, do you think I should just launch right into it then? And we'll see if Zeke can connect eventually. Uh-oh. See, I've already lost Kate's audio.
Can you hear me now?
I hear you now.
All right. Yeah, I think Zeke said he was trying to connect, so he'll be in shortly, hopefully.
Okay, so I will jump into the slides. The way this is going to work is we've got about, 14 slides, including the bookends, so really 12. 3 of them are intensely boring. I'll warn you about those. We're going to push through those and then get to the good stuff. This is going to last 20 minutes. Really, it's supposed to be 25, but you may have already noticed I talk a little bit too quickly. And then most of our time will be spent answering questions. So you can ask questions in real time in the chat. It's moderated, and we'll, as Greg said, we will get to as many. Well, we'll get to all of them as best we can. So launching right into it, the pictures you see are me about 15, 20 years ago. I might be a little bit different. You also see Dr. Zeke Blaine, who is trying to engage. He is our teddy bear. And I'm sorry you just heard that ding. That's people sending me. Okay, there I am back again. Sorry. That shouldn't happen again. We are at sort of opposite ends of the nuclear spectrum, which is why we're on here. I am actually an industry person. I graduated from RPI back in 1984. Yes, that's who I am. Worked out in industry, sort of teeter-tottered back and forth between industry and graduate school and had a grand old time. Don't do what I did. It's a long story. But the bottom line is, around the year 2000, my wife and I sort of looked at each other lovingly across the table and said, okay, who's going to stay home with the children we're about to have? And my full-time job right now is, in fact, stay-at-home dad. I am a part-time teacher at Rensselaer, part-time director of student services. It's a crock. Don't start applauding. Every now and then that happens. My oldest son is now in first year at university. My younger son is a junior in high school. They don't care if I'm home or not. So the transition is coming. But nonetheless, that's how I identify. I'm the guy from industry. Zeke is the guy from research. All right. He is intensely invested in the research community in many, many ways. That's what he's devoted his life to. You usually think as the research people as the stiff people. You can hopefully see from his picture, he's the teddy bear of the department. People just adore Zeke. Whereas me, I'm a vicious grader, and they don't like that. I'm friendly, I'm happy, but so it's not that bad. So the next 3 slides are the dull, boring ones. The first one, in fact, you'll get almost nothing out of, except for a couple of words. And I'm going to move there. So bear with me for 3 slides. Please, hang on. I need to click. This is our curriculum in a nutshell, the 8 semesters that you'll be here. And what I want to emphasize is not the thing you can't read on the right. You can get that from the catalog. I'm not going to go through that. Look at what's on the left. This is the plan that very few of you will actually follow, and for good reasons. The reason we admitted you is because you might not follow this plan, and that's good. We want innovators. We want people who are defining themselves and are not defined by some rigid curriculum. A side note, for those of you who go look at catalogs and compare curricula, which I encourage you to do, there's not a lot of engineering programs nuclear engineering programs out there, so you can make those comparisons. When you point your favorite search engine towards the Rensselaer catalog, please look in the upper right corner and make sure you're in the latest catalog. It'll be a drop-down menu. Look for the academic 2021, actually, I'm sorry, the 1920 catalog. It'll be right now. 2019-2020 catalog. Search engines, Google in particular, for some reason, love to either bring you to the 2007 catalog or the 2012 catalog, neither of which are current. Our curriculum has changed quite a bit since then, in many good ways that I'm very proud of. So again, make sure you're on the current catalog when you compare different programs. I'm going to zip right now to the next slide and focus in on the senior year. And again, I don't need you to look at the specifics because most of them won't make sense. What I want you to focus on are what's listed below. There's a full year nuclear engineering senior design project. Most capstone design programs that you see in other schools are mandated by ABET. They're the accrediting agency, and you just sort of do it. We're a little different. We actually spread it out over 2 semesters, so you really get a distinctive integrated experience. So you're defining the problem rigorously for an entire semester and starting trial solutions, prototyping things, putting up trial balloons. And then you go home for winter break and realize all the mistakes you made, and you come back fresh, new ideas, having had a rest, and launch back into it for an entire semester. So it's not just sort of 14 weeks, slam it down and done. This is a year-long process that you will follow with a team of students with you. That helps define you for part of your life. What the project you choose, the way you approach it, it can be a defining period of time that capstones the entire curriculum. You'll also notice 2 nuclear engineering laboratories. There are laboratory experiences here and there throughout the curriculum, but these are the crucial times. And what makes them crucial is we want you to be a skeptic. After 3 years of a lot of theory, a lot of book knowledge, and that's something that I'll talk about more later, Rensselaer is very much an analytically based school. We see the world through mathematical models. People get kind of annoyed when you just sort of build a nuclear reactor in your backyard and start it, and oh, that didn't work. Okay. So we look at mathematical models of things. We do prototyping. We do what-if scenarios. We look at safety analyses and put that together mathematically and then come up with the final product. So that's a lot of the analytical work for the first 3 years. And in the labs, you're supposed to turn to us and say, did you actually tell us the truth at all for 3 years? Is it real? And yes, this is where you get the chance to actually hands-on in nuclear systems with the linear accelerator and some of the laboratory equipment, the radiation dosimetry lab, saying, look at this, it actually works. Those of you taking physics right now in high school, they talk about projectile motion and it follows a parabola. And some of you are sitting there saying, no, it doesn't. I know it doesn't. I watch baseball. That thing's not a parabola. It's close. What's the difference? That's part of what laboratory is all about. And again, this comes up in theory, but nobody believes this. Why should they? Until you get this hands-on component. So again, a defining set of moments in your senior year. 2 nuclear engineering technical electives. This is also unusual compared to many other nuclear engineering programs. You might say, but I've already defined who I am. I'm a nuclear engineer. I'm not just, and this is not a pejorative, not just a mechanical, civil, electrical, chemical, the traditional disciplines where you do need to define what kind of mechanical are you. You might sit back and say, well, I'm a nuclear engineer. That's who I am. And somebody's going to say, what kind? And as we'll see later, there are many different kinds you can become. This is an opportunity, again, to define who you are to industry, to your peers, however you choose to do that. So there's a lot of freedom. Free electives. You'll notice that there are 4, 8, 12 credits of free electives in the senior year. Again, remember the previous slide. A lot of you, most of you, won't do that. You'll be taking your free electives throughout your 4 years here, your 8 semesters. But nominally, that's where they are in the schedule to help you define who you are. And then finally, there's that HAAS core, Humanities, Arts, and Social Sciences core, which is an important part of Rensselaer. And in 2 slides, that's where I'm actually going to start. Unusually, you thought you were here for nuclear engineering. I'm going to give you the broad overview of what we've got and focus more and more narrowly to where this senior year plays into your curriculum. So in doing of all that, then you're going to take, if you choose to come here as a nuclear engineering student, you'll take 130 credits total. 24 of them are humanities and social science courses. Again, compared to other schools, this is unusually high. More on that in a moment. 32 math science core, 24 core engineering, 38 nuclear engineering, 12 free electives. What does that mean? Don't worry about the numbers. We're going to talk about the importance of these categories and where they are. All right. So now we get into something. What are these humanities and social science, these and arts courses? And yes, the arts is a humanity, but it makes for a nice acronym. Both classic and modern topics, broadens your worldview, develops new skills, stress relief. If you're doing all engineering all the time, you can think more productively and a lot more if you have a philosophy class that's going to, and the psychologists will yell at me, but where you use the other side of your brain, which is not actually a good model, as you can learn from psychology and philosophy and neuroscience classes, the social science side of neuroscience. So it's a way to further define yourself. And this is crucial because when you go into an interview, most of you coming into Rensselaer are thinking, I slap down my Rensselaer degree and say, hire me. And they say, yes, of course. Thanks for applying. Well, okay, sometimes that does happen. But the number one question that an interviewer wants to know from you is, do I want you sitting next to my employees for the next 3 to 5 years? Are you interesting? Are you fun to talk to? Is there something that's going to make everybody be a team here? And having interesting things to do, having an outlet for creativity, of thinking in different ways, this is crucial. And Rensselaer has been a leader in this since the 1980s. When a guy named Bob Baum came to Rensselaer and said, engineers should really be thinking more. Actually, that was more in the 70s and the 80s. When I was here, it was just really starting up. So again, compared to other schools, you might say, well, I don't like to read. I don't like to write. I'm an engineer. Well, two things. One is get used to writing. The best way to get promoted in industry is to be a good writer and a good communicator. You can take courses to help you improve on that. All right. But you don't have to do that. There are humanities and social science courses in game sciences. There is not just economics, the traditional field. There's also econometrics for people who love the math and don't really want to talk about people and things like that. There's something for everyone. And I encourage you to go to the Rensselaer catalog and look at some of the pathway courses that we have in a huge diversity of areas. And I'll give an example. There was a woman who came to Accepted Students Day last year, and her big quandary was, well, I have two choices. I can come to Rensselaer, and she was actually going to be a mechanical engineer, but I can come to Rensselaer, or I can join the Houston Ballet. Wow, that's a tough choice. And one of the things she would do is if she came to Rensselaer, she would give up the ballet. It would be over. That would be it. That was her choice in life, one or the other. You can't do ballet, but we are directly at Rensselaer, but we are close to Saratoga Springs, where the New York City Ballet comes every summer, and there's a connection there. And we have the Impact, the Performing Arts Center, with lots of innovative things happening there, dance and so forth, that she could participate in and be an engineer, that way of thinking about the arts. And that's something crucial to say. We have humanities and social science majors here, but we are a polytechnic institute. So yes, you're here to be a nuclear engineer. Yes, we have some traditional classes, but mark me well, if you want a double major in 17th century French poetry, don't come to Rensselaer. We don't have that. You want to go to a very large state university to have that diversity. But if you know that you want to embrace technology and you want to be a nuclear engineer, one of very few programs is us. And our humanities and arts and sciences is, I would say, 50% sort of traditional, what you would expect, and 50% a Polytechnic Institute smorgasbord, all right, developed for people who are going to be the future engineers and scientists. So again, you don't need to wince and say, but I don't like my English class right now. I don't do social studies. There's lots more out there, lots. If you want to be a philosophy major, but just use logic, just alongside the computer science majors, it's there. So these develop crucial new skills that employers are looking for, that you have this breadth and diversity. So that's the Haas, not what you came here for, but something I need you to be very aware of that makes us significantly different from many other nuclear engineering programs. Then there's the core, the math and science classes. And this is the same for everybody, all right? There's mathematics, there's physics, there's chemistry. Chemistry is not just Chem 1 and 2, it's actually Chem 1 and then material science. Material science is crucial to nuclear engineering. Many of the new advances in nuclear reactor design, nuclear technologies, forensics, and so forth comes from the material side. So there's a real focus on that. But we're also trying to conceptualize basic principles. If you look in the lower right corner, the picture is a fluid network. And I mean, what does that mean? What is that? What is that complex system? What's it going to do for you? Being able to take something ultra complex like a nuclear reactor or a food irradiation system and break it down to its fundamental concepts that you can deal with, that's what your core is all about. It's trying to simplify things and give you the foundation, those mathematical models that we're going to use to look at what nuclear engineering is. And in particular, a thrust at Rensselaer is this data dexterity requirement. So you see the data in the upper right corner. This is actually a lab. I don't know if Zeke's in the background maybe, but this is a lab that Zeke invented. You take a couple of pennies out of your pocket. The one on the left is a copper penny. The one on the right is principally a zinc penny. Can't tell the difference unless you really know what to look for. You really can't tell the difference. You might feel a little bit of a difference, but not much. But by golly, every nuclear engineer knows the difference, or at least they can after you beam them and look at the radiation signature from them. But that's a wealth of data. If we just throw you into that lab as a first or second year student, it's meaningless. It's wasted on you. So we've got to build that foundation, and every school is going to do that. All right, those fundamentals. Something about Rensselaer, though, and because many of you are choosing between Rensselaer and other schools, and this is crucial to understand, we are on average, in order to fit these free electives, these Haas courses and all, we're a little bit faster. We're a little bit more challenging. Some of you may be taking calculus in high school right now. Calculus in high school, for many of you that are doing it in just Calculus 1 over the academic year, are going to spend something like 140 to 160 hours in the classroom studying calculus. We will give you the same calculus course in 52 hours. That's between 1/2 and 1/3 the amount of time. The responsibility for learning shifts to you. It's the same content, in fact, maybe more, a little bit more, shifted to you, the responsibility for learning. And so Rensselaer puts you into that challenge very early. Now, we have a tremendous support structure to help you with that, and we'll see that in one of the last slides. That, I think, is one of the shining things we offer to you. You say nuclear engineering, and you're like, wow, it's not rocket science. It's beyond rocket science. It's what's going to get us to Mars. The rocket scientists come to us for the answers, which is true. But we can still bring it down to human levels that all of us can be engaged with. But it is very challenging here. And that data intensity starts very early to acclimate you to nuclear data, which is a crucial part of getting it right and being safe, understanding the data. So the fundamentals are there. And then you move up, and simultaneously as the fundamentals, are core engineering courses. This would be your classic thermodynamics and fluid mechanics, like every mechanical and civil and nuclear engineer and aeronautical engineer does. Okay, these are the foundations that are common across many different majors. There's also, and this is what the pictures are about, your first major engineering design experience. Typically as a as a sophomore, second year student, you'll have Introduction to Engineering Design, which talks about the design process, gets you pushed into the room with hands-on. Literally, some of you have rebuilt your car engine, sort of the stereotypical engineer. Some of you have never touched a power tool in your life. We want you to have that understanding, that knowledge, to easily grab technology from the most mundane to the highest tech and be comfortable at all levels. So we're going to push you in there and get you into a machine shop and make you do things that some of you will be uncomfortable with, but you will come out with more confidence. And that's a crucial part of our education. We're trying to instill confidence, challenging you, but not pushing you so hard that you break down. This is not the military. It's a university where we're trying to get you to stand on our shoulders. All right. So we're going to start that way with these foundation courses. Then finally, except not finally, we get to the nuclear engineering classes. Now I say not because nuclear engineering is a little bit different from other majors. If you're not sure what you want to be and you want to decide to be a mechanical engineer, you can decide that at the end of your sophomore year. Nuclear engineering starts in the sophomore year. It is much more specialized, although before I said, but it's more generic. Well, we'll get to that. It's more specialized, so beginning first semester sophomore year, you will be taking your first nuclear engineering course, Nuclear Phenomenon for Engineering Applications. So you need to know by the end of your first year. So you have those common experiences, and your first year, you're going to be moving around. You're going to take Introduction to Nuclear Engineering as a 1-credit elective that you can take to explore. Here, it's a seminar course, basically. And you can take these fundamentals of flight with aeronautical engineering, and various other departments have their own. To explore, what is it you want to do? And as I said, moving around, you're going to go to professors' doors. Not necessarily go inside, just what kind of cartoons do they have on their door? Do you want to think like that person? Maybe you do. Maybe you should be that major. Maybe that's the right one for you. So it starts, but it's still general. And if you decide to change majors, they become just free electives, and that's fine. They can fit into your program no matter where you choose to be. But if you stay with nuclear engineering, eventually you get to those technical electives in senior year, or sometimes earlier, depending on how you progress. Again, you can call yourself a nuclear engineer, but some people might say, what kind? And there's the 4 classic areas of nuclear engineering. Power generation. I make a fission plant. I make a fusion plant. Nuclear systems, sometimes narrowed to what's called thermal hydraulics. That's the flow of heat and fluids to keep a nuclear power plant cool, coolant systems, safety injection systems, so on and so forth. But nuclear systems in general, you could think of the material systems, the radiation shielding systems, the criticality safety systems. These are all large-scale systems engineering questions that nuclear engineers need to know how to deal with and embrace. The big wide picture there is our linear accelerator in a panoramic view, a big long system that you need to be able to analyze and work with. Then, of course, there's the health physics and medical application side. Health physics is the concept of protecting people from radiation in its various forms, both cosmic radiation if you're an astronaut, terrestrial radiation sources that are natural, and then human-made radiation sources as well. And then medical applications, nuclear medicine has been at the forefront for many years now, and it's a huge area, and we will prepare you for that as well. So you can define who you want to be. And then finally, radiation technology is sort of the catch-all. If you want to work at CERN on their accelerator, if you want to do food irradiation, if you want to do forensics, if you want to do quality assurance using nuclear systems, that's radiation technology, the application of radiation to solve problems. So there's a variety of directions you can go in the nuclear engineering curriculum. And you see it's 38 credits. And again, people say, that sounds really narrow. One of the interesting things we find when you survey post-graduation, not just plans, but where do people go after 5 years? Well, the typical nuclear engineer from Rensselaer goes into the nuclear industry. But after 5 or 10 years, we're actually one of the most diverse majors there are. There's a remarkable number who go into law, who go into business. Part of it is because nuclear engineering, by its nature, has to take a large systems view. What is the big picture? And industry finds that, management finds that very useful, the law finds that very useful. So a remarkable diversity of directions you can go. The materials study that you do as a nuclear engineer is applicable to numerous different fields, remarkably numerous fields. We also have a number of dual majors in mechanical engineering, aeronautical. We actually have some with aeronautical engineering. These, again, are the people who want to do the space propulsion and get us to Mars. They also want to put their boots on Mars. People like that. A lot of dual majors with physics. Some of these dual majors can be done in 8 semesters. Some will require more time or require you to bring in AP credits. We can cover that in the Q&A later. But there's a lot of directions a nuclear engineer can go. The free electives. Again, 12 credits. This is dramatically more than most nuclear engineering and even engineering programs in general. That's a feature throughout Rensselaer, not just nuclear engineering. 12 free elective credits for everyone. It allows you to do a concentration, maybe even a minor in a different discipline. Again, if you come in with some AP credits or if you overload a little bit, you can push in a minor. But we're not, we talk about minors because they sell well, but when you actually come talk to us, we're like, do what you want to do. This is what the faculty thinks is a good, coherent program for this objective. What's your objective? That might be just a concentration. And you know what? If you put a concentration or a minor on your resume, people in industry pretty much see them as the same thing. They're going to say, what is that? Tell me more. And you have a good story for what you did. Maybe it's in computer science because data is a huge part of nuclear engineering. Maybe that's the direction you want to go. Could be in management. Maybe that you see managing a nuclear utility or work in a national lab in a management capacity could be your future. You can take a minor in management. So there's all sorts of different opportunities that you can use these free electives for. As I said, also dual majors, and then exploring personal quests. All right, you can do research. You can look at ideas of entrepreneurships. We have students who do startups, not so much in nuclear, Most nuclear engineering students from Rensselaer, actually remarkably, do not go to nuclear power plants. Some do, few. Most of them go to national laboratories or nuclear reactor vendors or design firms. They're sort of on the higher edge of excitement. Or if they do go to the power plants, they tend to rise very quickly. And that's, again, a feature you see. To the point where we could talk about this in the Q&A, but I joke with students. I said, RPI doesn't really get you your first job. We get you your first promotion. That's what we're really aiming at, and that path can be very fast. And I mentioned sculpture there because, and sometimes parents don't want to hear this, but, this is college. This is it. And it's your time to do really interesting things. And if you choose to take some of your free elective credits and put them into that art class that you've always wanted, why wouldn't you want to work with a world-class sculptor? All right. But that's between you and your funders and that kind of thing. So it's what you make of them. They're literally free for you to define who you want to be. And again, that student, if she decided she wanted to be integrated with ballet but still be a mechanical engineer, she'd be taking her 12 credits in the arts. All right, and everything else and her humanities and arts and social science electives as well, to get that identity of who she is as an engineer who's going to work in the world of theater. Who do you want to be? This gives you that large exploration capacity. Learning outside the classroom. Please do not come to college thinking that everything you need to learn will be found in books and from learned professors. It's not going to happen. That is one of the challenges at Rensselaer, and it's something you need to be aware of. We are a challenging school. There's no doubt about it. It is hard here. Now, this is crucial to also know, because I always get criticized. Don't tell them that. Well, they don't say that, but we accepted you because we believe you can make it. You would not be accepted if we didn't think that you could rise to this challenge and do just fine here. All right, so it's not a fear. I'm just telling you, it is hard. Time management is a crucial part of that because you don't want to just be taking classes. You do want to stretch out and spread your wings. You want to join the American Nuclear Society. You want to go to these conferences. That requires time management. All right. And for these extracurricular activities and clubs where you're going to get a lot of the knowledge, a lot of the hands-on learning that you crave while you're doing your theory before you get to some of the more advanced laboratories, that is a crucial part of this. And then, of course, co-op jobs and internships and so forth. There's a picture of the career fair. Everybody, once a semester, lots of companies come and you're all milling around there. It's a little different for nuclear engineering. Of course, there are big companies. Knowles Atomic Power Lab shows up. The national labs will show up. Sometimes GE will definitely show up. Sometimes Westinghouse and others. But I myself, when I worked in industry, I worked at a consulting firm for 16 years. After working with Westinghouse a bit, I worked as a consultant in a company that started with 3 people, my boss, his wife, and me. And we grew to a colossal 7 people by the time I left to become a stay-at-home dad. And it was absolutely fabulous. Those kinds of jobs don't come to the career fairs because they only need one person every 5 years, something like that. So there's a little bit of pavement pounding, but nonetheless, within the program, we are very aware of that. And we're constantly wanting to make connections with national laboratories and with the vendors. And we have a lot of alumni out there who are looking out for you. All right. So yes, we're a small program, which can be very nice, but you sort of think at the end of the day, is there a need? There's a colossal need for nuclear engineers. There is a shortage, a continuing shortage of nuclear engineers. I don't see it going away anytime soon. Now, if you want to go into fusion, when I took my first fusion course as a junior in 1983, I loved the course, but I also figured out that fusion would not be here until I was, at least what I wanted to do in fusion, not the physics side, the balance of plant engineering. It wouldn't be here until either I retired or I was dead. And so far, my predictions are proving true. All right, so I'm sorry for those that want to do fusion here. I would not recommend Rensselaer as the premier fusion school. Yes, we can give you all the fundamentals. You don't need to go here for fusion. You need the fundamentals, and then you go do your PhD at a fusion-centric school. All right, you'll get all the good fundamentals here. On that note, I should also mention we have a remarkable transition to graduate school from nuclear engineering. We're much higher than most other disciplines, not just at Rensselaer, but throughout the nation. I think it's something like 30%, 35% of nuclear engineers go on for a higher degree. Some of them immediately, many of them immediately after completing Rensselaer, either by staying here. We have our co-terminal program for a master's or the BS to PhD program. Others leave, go elsewhere. We've got people out at Berkeley right now doing great stuff. In fact, one of them just came back, is working at Knowles Atomic Power Lab over in Schenectady now. So there's plenty of opportunity, and it can be a long educational career before you go to industry or the national labs, or it can be the 4 years and you're fine. You do not need a graduate degree in nuclear engineering to go right into industry and participate fully. You do not need that. There's no we encourage it. Many people do it, but it's not vital in nuclear engineering by any stretch. All right, so this is actually, those of you that attended the presentation that Diana Borka-Tausig and I did for mechanical engineering, this slide I stole right from her, student advising. This is one of our hallmarks, and she sort of woke me up to this too. Her kids are also going to college, and she's really learned firsthand how good we are. I was about to say how appalling the rest of them are, but that's a terrible thing to say. How really good and focused we are. We have a full team here that is ready to work with you, because as I noted earlier, that curriculum plan, most of you aren't going to follow it. We will help you navigate that. The hub team that you see in the lower left corner, that team is there for all engineers in your first year to help you navigate that path and figure out who it is you want to be, give you tips and tricks and techniques to get that under your belt and to move forward from there. In the lower right, you see our student services. That's me, the guy with the tie. It's more in my nuclear tie today. It's just a thing. When I first started teaching, I had just come from industry, where as a consultant, you sort of wear a tie to say, I know what I'm doing, whether I do or not. But I came to university then with little kids, and I had to remind myself that I was playing with adults, not playing with young children. So I would wear a tie. That was my distinguishing prop to say, "Oh, I'm playing with adults now." And that's really what nuclear engineering is about. We really play a lot. We play hard, but we learn a lot, and it's just great fun. But anyway, there's the guy with the tie, and then there's Kate and Julie. Kate, who's on this webinar, and you'll see her again shortly as I open it up, and she's answering many of your questions. And then there's Santa, and stress relief is what it's all about. Our department, thanks to Kate, hosts the Cookies and Cocoa with Santa every winter. And we've had various other activities that go on to try and, so it is challenging here, but we try and make it wonderful, and we give you the tools you need to navigate. A lot more personal attention and availability than I have seen for my kids and that others have seen for their kids going to college. So that also is a Rensselaer feature. So those are the big picture items. The next thing is just the question slide and then the we're done slide. So I'm going to leave it on